Does it really exist? Many experts suspect that a gigantic mysterious planet is hidden in the furthest reaches of the solar system. A few years ago, us astronomers uncovered a series of strange anomalies in the Kuiper Belt that point to the existence of a large celestial body, and now the hunt for Planet 9 has been given new fuel, and a research duo is certain that the undiscovered planetary world must exist. But what have the experts discovered? Why has the existence of Planet 9 not yet been confirmed? And why is it so difficult to track it down? Where do comets actually originate? Well, for a long time the answer to this question was simply somewhere out there. In 1950, the Dutch astronomer Jan Hendrik Oort proposed a bowl-shaped zone at the edge of the solar system that serves as a reservoir for common nuclei in order to narrow down this rather rough location. Ultimately, however, Oort's cloud was only able to explain the orbits of long-period comets in order to decipher the background of their short period counterparts. A further approach was needed, which the astronomer Gerard Kuiper provided the following year. Ultimately, however, it would take another 40 years before the existence of the isolated Kuiper Belt was officially confirmed. This ring-shaped structure of icy debris extends just beyond the orbits of Neptune and Pluto, and it may not just be home to comets, frosty chunks, and small planets. For some time now, the Kuiper Belt has also been suspected of hiding something literally bigger, a huge planet that orbits far beyond the orbit of Neptune and which has so far successfully managed to hide itself from our terrestrial gaze. But how is this even possible? Can it really be that we have simply overlooked a member of our planetary system for thousands of years? Well, actually it is. The planetary mystery is said to be so far away from us that no telescope has yet been able to capture it. So where the object of desire appears invisible, other paths must be taken to crack the cosmic puzzle. And if anyone knows how to rewrite the maps of space, it is the American astronomer Michael Brown. In fact, Brown has been searching for icy worlds at the edge of the solar system for some time now. He named the largest one he has found so far AIS, and with the discovery of the dwarf planet, Brown made a significant contribution to knocking Pluto out of the ranks of planets. In 2006, interesting to know, the astronomer has been on X as Pluto Killer, but perhaps his account will need a new name update in the foreseeable future. According to the account, the objects that Brown referred to as distant detached objects formed the basis of a research study that led Rodney Gomez's team to a groundbreaking conclusion. In 2006, a completely unknown planet could actually be slumbering in the extreme world of the Kuiper Belt on the hunt for Planet 9, and Brown subsequently also took part in the planet hunt at full speed. In 2016, the Pluto Killer teamed up with his colleague Konstantin Batyn to investigate the question of what the unusual orbits of some Kuiper Belt objects were all about, and lo and behold, 6 of these objects follow an elliptical orbit that points in the same direction. Even though all the bodies move at different speeds and their orbits are not the same size, the collective orbital inclinations are no less striking. The orbits of all 6 celestial bodies deviate by around 30 degrees from the orbital plane of the remaining planets and objects in the solar system. It was immediately clear to Brown that this simply could not be a coincidence. He put the corresponding probability of this at 0.7%. The astronomers initially suggested the gravitational effect of several heavy objects such as a group of dwarf planets as an explanation. However, this approach was immediately rejected in the subsequent model calculations. After all, the Kuiper Belt would have to be 100 times more massive than it is. According to the investigations, Brown and Batyn carried out further simulations and finally came to an exciting conclusion. All the anomalies observed could be explained by the existence of a planet about the size of a 9/10 of a meter whose orbit is shifted by 180 degrees to that of all the other planets and Kuiper Belt objects. And while this baffling orbital geometry initially left the researchers baffled, they gradually realized that more and more observations were consistent with the existence of such a Planet 9. For example, the orbits of the trans-Neptunian object Sedna and another large celestial body could also be perfectly explained by the presence of an unknown planet. Why we have not yet found Planet 9? The astronomers' calculations have shown that Planet 9 weighs around 10 Earth masses and that it orbits the Sun at a distance of around 400 to 1500 astronomical units. A quick reminder: the length of an astronomical unit corresponds to the average distance between the Earth and the Sun, or in other words around 150 million km. And while our blue home planet is known to need 365 days to orbit our central star, once Planet 9 is said to need up to 20,000 years for this undertaking. Due to its distant orbit, the mysterious celestial body is therefore beyond the range of our normal telescopes most of the time. Added to this is the fact that Planet 9 is in all probability very faint. Model calculations by a team from the University of Bern have shown that its intrinsic luminosity is only 0.0 06 Neptune has a value of 0.01 in this category, but that's not all. The little radiation emitted by Planet 9 could also be mainly in the infrared range. As a result, its temperature would have to be around 47 Kelvin or 226 degrees Celsius, which in turn would make it only around 37 degrees warmer than its cosmic surroundings. Despite all this, however, it's not impossible that the unknown member of our home system could still come to our attention. If the planet is currently close to its closest point to the Sun, it could even have appeared unrecognized in the images of past sky surveys. If on the other hand Planet 9 is very far away from the Sun, the groundbreaking bullseye could have landed with the help of a powerful telescope such as the Vera C Rubin Observatory. However, the reflecting telescope is currently still under construction and its commissioning is planned for March 2025 at the earliest. But even if the existence of the celestial body were to be confirmed in the course of future research missions, we would not only be one planet richer, but also with some big questions. The problem of formation. According to conventional wisdom, large planets are formed ere the primordial cloud provides sufficient matter. No wonder, after all, the reservoir of gas and dust is only sufficient there to gradually form ever larger chunks and ultimately also planets. But this is precisely where things get tricky. In the case of Planet 9, with an average distance to the Sun of 700 astronomical units, it orbits far outside the zone in which the primordial cloud had enough material for planetary giants. What a celestial body that is 10 times heavier than the Earth and only slightly smaller than Neptune is doing in such a remote and eccentric orbit is very difficult to explain with our current models of planetary formation. It is also very difficult to explain the fact that according to a simulation, Planet 9 must have a similar structure to Neptune. According to this, we are dealing with an ice giant with a solid core, half of which consists of iron and rock and the other half of water ice. The outer layer of ice is in turn surrounded by a dense gas shell of helium and hydrogen, and that is precisely the problem. In fact, Planet 9 could only have built up this envelope if it had been in the gas-rich heart of the primordial cloud for a sufficiently long time, and yet, if Planet 9 really exists, then it must have formed somehow. With this in mind, astronomers are currently discussing 3 different scenarios that could have paved the way for the planet's birth. The first approach is based on the assumption that the planet formed on the spot whereby it originally still had a normal, almost circular orbit in the planetary plane. The passage of a nearby star then led to Planet 9 drifting into its current exotic orbit. However, this scenario also presupposes something that is not consistent with our current models. The primordial cloud of the Sun would have had to have been significantly larger and longer lived than generally assumed. However, the evidence that the gas nebulae disintegrated again just 4 million years after its formation seems to speak against this theory. In addition, Planet 9 would probably have been completely ejected from our system as a result of its stellar dichotomy. However, the second model is also based on a stellar approach. In detail, the siblings of the young Sun could have led to the fact that we are now one planetary puzzle richer. According to this model, the star cluster to which our young host star belonged was torn apart by galactic tidal forces, and the stellar family was separated from each other before that. However, the Sun could have stolen Planet 9 from one of its siblings. According to one simulation, the planet would have had to have been in a very wide orbit around the stolen neighboring star, but as our early central star approached within the star cluster to around 150, its gravity caught the celestial body. All in all, however, astronomers put the probability of this planet theft at just 1%. The third and final scenario appears somewhat more promising. According to this theory, Planet 9, just like Jupiter, Saturn, Uranus, and Neptune, was formed in the inner regions of the primordial cloud. A few gravitational interactions and turbulence later, the large celestial bodies were then steered onto orbits that were significantly further out. As the outermost representative, Planet 9 was pushed the furthest away and finally catapulted into an eccentric orbit. The crux of the matter, however, is that Planet 9 would have been thrown completely out of the solar system again unless it was slowed down by the dense gas of the primordial cloud or a nearby star passage. And indeed, a discovery outside the solar system shows that this is entirely possible. In detail, astronomers have tracked down an exoplanet that orbits its double star system in a similarly extreme orbit as postulated for Planet 9, a good 335 light-years away from us. The gas giant HD 10696b orbits its 2 stars at an inclination of 36 to 44 degrees, approaching them to no more than 500 O. As a result, the exoplanet also provides proof that such exotic and extremely distant orbits are actually real. What's more, in the corresponding system there are clear indications that the comet belt and the outer dust disk are unevenly distorted. This in turn could indicate that the exoplanet was only brought into its orbit later, exactly as is assumed for Planet 9. However, the existence of Planet 9 has not yet been confirmed. The galactic search continues at full speed, and astronomers hope that new and more powerful telescopes such as James Webb will soon help to finally crack this planetary missing persons case. Fortunately, the case of the missing subscription button can be cracked very quickly. It is hidden directly below our video and is already waiting for you to click on it. So join our community now and never miss an exciting video from us again.